Now, if you look at the diagram, and I'll give you a better diagram in a moment in the books, you can see that what we have here now are two metals in contact. And for our first example, it's zinc and iron. It's very hard to read them. But if you find them on your electrochemical series, which one is the stronger reducer? The zinc is a stronger reducer. So when we have two metals in contact, and I'm just trying to find a whiteboard marker to both of them on. The stronger reducer is oxidized. And what we can see from our diagrams is that with the two metals in contact, we have the opportunity for electrons to flow through the metals. Because zinc is the stronger reducer than iron, this is the one that's oxidized. What happens on the iron then? What's the other half equation? Well, that would be oxidation of the iron. I mean, when the two metals are in contact, only the stronger reducer is oxidized. So what's the half equation that happens on the iron?
The I2 plus 2H2.
Yeah, that one. Because this is still corrosion. Okay, and so this was our oxidation and our reduction. O2 plus 2H2O is 4E minus goes to 4OH. And so what we'd end up producing is what? What would our product be if we combined those two half equations?
Zinc hydroxide.
Yeah, zinc hydroxide. So we have to remember that in all cases of our corrosion, this is our reduction half equation. We can't reduce the iron any further because remember, reduction is adding electrons. And we would have to then make a negatively charged metal ion, which is not going to happen. Now, with these two metals in contact, the redox reaction is actually accelerated. This will happen faster than the oxidation of the zinc would have happened if it wasn't in contact with the iron. Does that make sense? Why do you think it's faster? What? Sorry?
Because the electrons are flowing.
Yes, we've got this electron pathway between the two metals. And there are some interesting examples of this being a problem. One of them is around your house. if you have, some people have copper pipes. The water goes through copper pipes, and or it could be that you've got steel pipes. Just say you had steel pipes, and we're going to say that they're mainly iron, and you're getting all this rusty water out of the tap, or the tap's rusty. You go to the hardware store and you decide you're going to replace that rusty tap with a copper tap. Okay, what's going to happen? If you look at the electrochemical series, what's going to happen if you change out that steel tap for a copper tap?
The reaction will happen faster in the pipes, so the pipes will oxidise more with the iron pipes?
What we have to look for to start with is which one is the stronger reducer? The iron. And the iron, we know, with those two metals in contact, it's the iron that will oxidise. Yes, and so you're right.
Yeah.
You're going to rust out your pipes. And it's a whole lot easier to change a tap than it is to change all the pipes. So you need to be aware of the interactions that you can be causing. What about the Statue of Liberty? It's an external copper, that's what the statue is made of, but inside is a steel framework. What's going to happen with the copper and steel for the Statue of Liberty? The steel will rust. And that is the actual framework that holds the statue up. And in fact, they had to spend a lot of time and money fixing it up because it was getting to be a bit hazardous. Aluminium in boat in contact with a steel attachment like an anchor. What's going to happen with the aluminium boat? Just say you've got a steel anchor and you bring it up, it's all wet and with salty water, and you just sit it in the hull of your little aluminium dinghy. What's going to happen over time?
The aluminium will corrode faster.
Yeah, so you might end up with a hole in your boat. That's probably not a good thing. So what we need to think about are these two metals in contact. What about the battery terminals that are made of lead and connected to steel body parts? What's going to happen? Which one is the stronger reducer?
Steel.
Yeah, the steel. And so you might end up rusting the car if it is in contact with those lead terminals on the battery. Okay, can you sort of conceptualise of this transfer of electrons happening through the metal, and that means that we are going to oxidise the stronger reducer. Alrighty, there's question 17 and 18 on the next couple of pages, so I'll get you to work on them, and then we'll move on to the next section.